This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're going to find the exact value of sine of 66.5 degrees using a half angle identity. So this means we want to write 66.5 degrees as half of some angle. In other words, 66.5 degrees is what divided by 2. Well, the easy way to get this answer is you do 2 times that number, and that would be 135 degrees. So the sine of 66.5 degrees is the same thing as asking what's the sine of 135 degrees over 2. And now we have a half angle identity for the sine of x over 2, and in this case our x would be 135 degrees. So let's just write that identity down here. The sine of x over 2, I'm going to use this identity. It says plus or minus the square root of 1 minus cosine of x over 2. Well, obviously the sign can't be both positive or negative. So now what we're going to have to do is look at the original angle up here, the sine of 66.5 degrees, and decide what quadrant 66.5 degrees is in, and then from that determine whether the sign will be positive or negative in that quadrant. Since 66.5 degrees is in quadrant 1, everything's positive in that quadrant. So I could go ahead and say it's going to be positive. It's not based on 135 degrees, it's based on the original angle. All right, so just keep in mind that 66.5 degrees, it's in quadrant 1. Okay, where the sign is positive. All right, so then we could go, we've decided it's positive. Now we're going to use this formula. But remember, we're going to put in the cosine of 135 degrees, right? That's the important point here. That's what our x is. Okay? So what does this give me? 1 minus the cosine of 135 degrees all over 2. Make sure you put the 2 underneath inside the square root. Right, now we have to compute the cosine of 135 degrees. So let's do that over here on the scratch. That's over in quadrant 2, 135 degrees. Now I know some of you memorize it or use the unit circle. I always draw a picture each time to figure out the answer. And that is negative 1 over square roots of 2, because it's the x basically over the r, or negative square roots of 2 over 2. That's how I'm going to write it. I'm going to write it where I've rationalized the denominator. So I'm not going to put that positive sign again, because if I leave it off, it's obviously positive. So I get 1 minus square roots of 2 over 2 all over 2. Now I have this complex fraction underneath this big old square root, and so you have to deal with a complex fraction. Now, there are lots of ways to deal with complex fractions. My favorite way is you multiply the numerator and denominator by the least common denominator. Now, there's no denominator in the denominator except 1, right? This is thought of as 2 over 1. So there's really only one denominator in the whole problem that you have to be concerned with, and this is this 2. So I am going to, inside the square root, multiply the numerator and denominator by 2. Now, to do that, I should make this look a little bit bigger. Here we go. Okay. And you could always do this on scratch work. You could simplify this. So when you do this, you'll eliminate this denominator where we've got the square root of 2 over 2. So I need to do the distributive property in the numerator, and this is still all going to be under one big square root. 2 times 1 is 2, minus, now 2 times square roots of 2 over 2, the 2's will cancel. So I still have that square roots of 2. And in the denominator, I have 2 times 2, which is 4. And now that's the same thing as the square root of the numerator all over the square root of the denominator. And 4 is a perfect square, so I could simplify this a little bit further. Let's try to get this all on one page. So that will give me, oops, I wanted to write the smaller one. So in the numerator, I just have the square root of 2 minus square root of 2. And in the denominator, square root of 4 is simply 2. Now, if this was like square root of 3, then you would also have to rationalize the denominator. Usually we write the answers where at least the denominator is rational. And so there's our answer. I know it doesn't look nice, but sometimes you have a square root inside some other square root. And so here we've now got our answer for the sine of 66.5 degrees. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.